8086 microprocessor addressing modes. Introduction to addressing modes. Program. A set of instructions written to solve a problem is called program. An instruction is directions which a microprocessor follows to execute a task or part of a task. Coming to the computer language is divided into two types. It is high level and low level. When coming to low level, again it is divided into two types, machine language and assembly language. Machine language is represented in binary bits and assembly language is represented with the English alphabets, mnemonics, assembler mnemonics. Addressing modes of 8086. Every instruction of a program has to operate on data. The different ways in which a source operand is denoted in an instruction are known as addressing modes. There are 14 addressing modes in 8086 microprocessor. These 14 addressing modes are divided based on two types of instructions. Those are sequential control flow instructions and control transfer instructions. Under sequential control flow instructions, the execution control is in sequence. That is, if the processor is executing the third instruction, it will execute fourth instruction and after that fifth, sixth, that is in a sequence. And coming to the control transfer instructions, in that the execution control is transferred to some other location within the segment or outside the segment, but not the current one. Then under the sequential control flow instructions, there are 8 addressing modes and under under control transfer instructions, there are 4 addressing modes. Register addressing, immediate addressing, direct addressing, register indirect addressing, based addressing, indexed addressing, based index addressing, relative based index addressing, and coming to control transfer, intra-segment direct, intra-segment indirect, inter-segment direct, and inter-segment indirect. These are the 14 addressing modes which comes under 2 types of instructions. Coming to register addressing, the instruction will specify the name of the register which holds the data to be operated by the instruction. That means the source operand and destination operand both are registers in this addressing mode. The content of 8-bit register DH is moved to content of 8-bit register CL in the example move CL, DL. The content of DH is moved to. Coming to immediate addressing. In immediate addressing mode, the 8-bit or 16-bit data is specified as a part of instruction. For example, move DL, 08. The immediate data 08 is moved onto the 8-bit register DL. When move AX, 0A9FH. The 0A9FH is a 16-bit data that is moved into the AX register. Addressing modes which results to memory access. There are 20 address lines in 8086 microprocessor. 8086 can address up to 2 power 20 is equal to 1 megabytes of memory. However, the largest register is only 16-bit. The physical address will have to be calculated as actual address of a byte in a memory, that is, the value which goes out onto the address bus. Memory address represented in the form of segment and offset address. Each time the processor wants to access memory, it takes the contents of a segment register, shifts it one hexadecimal place to the left and add the required offset to form the 20-bit physical address. Addressing modes. Direct addressing. Here, the effective address of a memory location at which the data operand is stored is given in the instruction. The effective address is just a 16-bit number written directly in the instruction. Move BX, in the braces 1354H. The content of the memory location within the square braces, that is 1354H, is moved into BX register. The square brackets around the 1234H denotes the content of memory location. When it is executed, the instruction will copy the contents of the memory location into BX register. This addressing mode is called direct because the displacement operand from the segment base is specified directly in the instruction. Next, register indirect addressing. The register indirect addressing, the name of the register holds effective address will be specified in the instruction. Registers used to hold EA are of any of the following: BX, BP, SI and DI. Content of the DS register is used for base address calculation. EA, effective address, is stored in BX and base address is ds into 16 bit 16 multiplication, and based addressing. In this addressing mode, BX or BP is used to hold the base value for effective address, and assigned 8-bit or unsigned 16-bit displacement will be specified in the instruction. In case of 8-bit displacement, it is sign extended to 16-bit before adding to the base value. When BX holds the base value of effective address, 20-bit physical address is calculated from BX and DX. When BP holds the base value of EA, BP and SS is used. For example, move AX comma in the braces BX comma 08. Indexed addressing. In this addressing mode, it is used to hold an index value for memory and data, and a signed 8-bit or unsigned 16-bit displacement will be specified in the instruction. Displacement is added to the index value in SI or DI register to obtain the effective address. In the case of 8-bit displacement, it is sign extended to 16-bit before adding to the base value. For example, move CX comma in the braces SI plus 0A to H. Based indexed addressing. In this addressing mode, the effective address is computed from the sum of base register and index register and displacement. Move dx comma in the braces bx plus si plus 0ah. In relative addressing. In this addressing mode, the effective address of a program is specified relative to instruction pointer by an 8-bit displacement JZ0AH. In this 000A is sign extended. If ZF is equal to 1, then effective address is present in IP plus the effective address, and base address is calculated the code segment into 16 decimal value, and the 20-bit physical address is formed by adding the CS plus IP. If the ZF is equal to 1, then the program control jumps to new address calculated above. If the ZF is equal to 0, the instruction of the program, the next instruction of the program is executed.